Hi, this is Group 29, and our project is applying machine learning methods for cat and dog breed identification. Here's the table of contents of our presentation. A staggering of 66% of the US households own a pet, and the majority of them have the cats or dogs. Understanding the cat or dog breed is not just a matter of curiosity, but it can provide valuable information about the pet's care and well-being. Despite the popularity of these pets, many owners just do not know their exact breed, and this might lead to some misunderstanding and mismanagement of their pet. Having a tool to classify the breed will not only help the owners, but also assist the vets, especially those who just start their careers. Although DNA tests are available, it can cost a lot and are very inconvenient.
We used the Oxford dataset for training, and the dataset contains 37 categories with around 200 images for each category. The photos are pretty informative, so it should be a good source for our model training. The visualization of the dataset shows the effective number of images we can fetch from for each breed, and it's around 200 images for each breed. We employed three supervised classification algorithms like SVM, the CNN model with simple net, and pre-trained ResNet model. Before the model training, we first finished the data preprocessing. For SVM, we resized each image to 128 times 128 pixels. We converted images to grayscale to simplify the feature extraction process, and we use the HOG to capture edge and gradient structure. For CNN models, we feed in the raw pixels after data augmentation by using the tag vision transforms.
So the method one we use is the SVM. An SVM was deemed appropriate due to its robustness and capability to handle high-dimensional data, and our data with the images of those cats and dogs are definitely one of those high-dimensional data. Second method we use is the CNN model with the SimpleNet. The SimpleNet used raw pixel values from image data as input, and for data augmentation purposes, some methods such as scaling, random horizontal flip, and color jitter were used to improve the feature learning capabilities. After those data augmentation, we use convolutional layers to extract the features and FC layers to learn predicting the labels. SimpleNet show a better result of feature learning compared to that of the support vector machine. The third method we use is the ResNet. The ResNet model was pre-trained on big data set, and we preserve and lock the parameters, just alter the FC layer to fit our own data set. The ResNet model outperformed the previous ones because it has deeper variant with more layers, and the increased depth allowed the network to learn more complex features at the cost of higher computational requirements. The ResNet 50 has reached the accuracy of 75, which is pretty good.
The confusion matrix and accuracy for each model are shown here. We can see the accuracy of SVM and SimpleNet model are 0.14 and 0.25 respectively. The accuracy increased a lot for the ResNet models, and you can see the diagonal blocks have deeper colors than the other blocks, meaning the algorithm is capable of predicting the correct label. The accuracy achieved by our SVM model is about 14.2% compared to the 2.7% of our random classifier. The SVM model does show some better performance. However, the improvement margin is still slight, and there are several factors like feature limitations and grayscale information loss should be contributing to the suboptimal performance.
For the simple net, we used it with convolutional and fully connected layers, and we achieved the accuracy of 25%. It just outperformed the SVM, but overfitting still occurred. Attempts to address overfitting with the weight decay still can't break the limits of 30%, and hyperparameter tuning just showed that this method is just too simple. And the ResNet we used, due to the deep nature and big capacity of that, the model improved accuracy a lot. We can achieve final accuracy of 75% with the ResNet 50 model. Our model still perform poorly on some certain classes, but for the other classes, it can do predictions pretty well. Here are the general concerns of our methods. First, the data quality and quantity. Many of the classes contain less than 200 images in total, and raising that number will definitely contribute to gaining a better result. Our images have lots of noises, and that reducing the noises will also lead to a better result. The hyperparameter setting, we just lack some hyperparameter tuning to find the best ones. And for color retainment in real life, color matters in identifying the breeds. But if we don't apply the color jitter, the background color will also be an intervene. And that is the issue and concerns here.
As a conclusion, the ResNet 50 model is the best one to predict both cat and dog breeds, since it has a very high accuracy score, which is above 0.75. For the future, we can do several steps. First, we can optimize learning rates and other hyperparameters. And second, we should focus on solving the problem of color, since it's pretty important when identify the breeds. Third, we'd better combine multiple models like SVM and other supervised learning models. And lastly, we should find more datasets and train on them. This is our references and the timeline and contributions table.
And
Thank
that's
you.
it. Thank you.